So today we're going to be talking about lesson 3-4, which is polynomial functions. So we learned about polynomials, but polynomial functions have some other restrictions on them that we need to talk about today. So a polynomial function is a function that represents a polynomial equation, and it's a continuous function that can be described by a polynomial equation in one variable. Okay? So if there's more than one variable, you know that it's not a polynomial function. Now, there are various types of polynomial functions, but they're all continuous. Does everybody know what a continuous function is? What the difference between a continuous and not continuous function is? It does go on forever. What it means is that if you put your finger over the function and go left to right, you're not going to have any gaps. You're going to be always touching the function. So you can trace it through, and you're always going to be touching the function. There's no holes in the function, basically. Okay? So there's some polynomial restrictions on polynomial functions that we have to talk about. So finite number of terms. Okay? We have to have a finite number of terms. All right? Finite number of terms, basically no variable under the radical. Okay, so see here, as we can see, this is a square root of a variable. This is no. We can't have that. It's not a polynomial. No variable in the denominator. So if you have a variable in the denominator, not a polynomial function. One variable only. You can only have one variable. Okay? So as you can see here, this is two variables. This is no. We can't have that. And no negative exponents. You can't have negative exponents or it's not a polynomial function. So you got to look out for these no-nos to make sure that you're really looking at a polynomial function. So there are four main types of end behavior to polynomial functions. So you look at two main things to determine this. So before you look at anything to do with end behavior, you need to make sure that your polynomial is in what we call standard form. Okay, standard form means decreasing degree order. So we all learned about how to put it in standard form. Everybody remember doing that? Okay, so the first thing you look at is your leading coefficient positive or negative? And the next thing you look at is the degree, the exponent on that term, even or odd. So if your exponent is even and your leading coefficient is positive, the end behavior is that the function is going upward on both sides on the end. So go ahead and write that. Now, if your leading coefficient is negative and your degree is even, like x to the second, x to the fourth, then you're going to end up going downward on both sides. Now, if your degree is odd, like x to the first, x to the third, x to the fifth, and so on, but your leading coefficient is positive, like a 2 or a 1, then you start down and you end up upward. And if your leading coefficient is negative, like negative 1, negative 2, negative 3, and your degree is odd, like degree of 1, so like x to the first, x to the third, you're starting upward and ending downward. Okay? So that's the four types of end behavior. So this chart is going to be like your best friend in this lesson. So you're going to be referring back to this a lot. So it's really important that you have these down correctly. So just double check, make sure you have them down correctly. Now we're going to talk about the 6 main types of polynomial functions that you're going to be looking at. The first type is a constant function. This is just y equals some number, and this is degree 0. So this is always just a straight horizontal line. Okay, it can be shifted up, down on the axis to be lower or higher, but it always looks like that. The next one is a first degree, which is just a linear function. Okay, first degree is a linear function. Next one is a quadratic function. Okay, second degree, cubic function, third degree, I almost said quadratic. Quartic function is degree 4, and quintic function is degree 5. So the general shape of polynomial function shows the maximum number of times the graph of each function may intersect the x-axis. This is the same number as the degree of the polynomial. So we're going to talk more about this as we go through the lesson. Does anyone have any questions about the end behavior chart? All right. Hang on, we got a question. All right, so we're looking at this question here, which is question 1. Okay, so for question 1, The first thing we always check, we're trying to determine the end behavior of these both, okay? I don't know, I'm sorry. So, we have a function here, and the first thing we just have to check is this function in standard form? So do we have decreasing degree order here? Do I have to reorder the terms? Yes or no? No. See how it's in standard form? Does everybody see how it's in standard form? Okay. So now that we've determined it's in standard form, we got to look at that first term. This is going to tell us everything we need to know about this polynomial function. Is the coefficient positive or negative? Positive. Is my leading coefficient exponent, okay, is my leading exponent term, is this even or odd? Even. So this is positive even. So what does the end behavior look like for positive even? I think it's down then up, right? Down then up. Does that match it? Oh, my bad. I'm thinking positive odd. Yeah, you're right. My bad. For a second, I thought we were doing odd. So yeah, it's up and up. Everybody good with why it's up and up. So basically what this function looks like, I'm going to sketch it for you guys just so you have an idea. So the sketch of this function is going to go, so it's going to go down, it's going to look something like this, okay, because it's a fourth degree. So it's going to be basically going up at both ends. See how the endings both end up upward? So now we're going to determine as x goes to positive infinity. So I want to talk about what that means. So as x goes to positive infinity, that means the value's over here because x is getting bigger. So as x goes to positive infinity, what happens to your function as it goes this direction? Does your function go up or down? Up. So your f of x, your function, goes to positive infinity. Now, if we're looking over here, as my x values go to negative infinity, so as my x values go down, what happens to my function? Does it go up or down? Up. So it's also positive infinity over here. So that's how you determine the end behavior. So any questions so far? All right, let's try another one. So we check and we make sure, are we in standard form here? Should be an equal sign right there. Are we in standard form? Yes or no? Yes. Yes, we are. We're in standard form. So we look at our first term. Is my coefficient, leading coefficient odd or, I'm sorry, negative or positive? Negative. Good. And is my exponent even or odd? Even. Even. 2 is even. So it's negative even. Make sense? So what's the end behavior look like for that? Both the arrows are downward. So what this function would look like, okay, this is just a rough sketch, but I'm just giving you an idea. So this is a quadratic function where it goes down on both sides, okay? So, as my x values go to positive infinity, what happens to my function? Does my function go up or down? Down. So this goes to negative infinity, my function does. Now over here in this direction, as my graph goes, my x values go to the negative direction, okay? My function goes down. Any questions about that? Any questions at all? You guys starting to get the idea? Moving on to number 3. So this is in standard form because there's only one term, right? So is my coefficient positive or negative? Positive. Good, positive. And is my exponent power odd or even? Odd. Positive, odd. What's the end behavior look like for that? Down then up. Very good. So what this function looks like, if I draw a rough sketch, this is a cubic function. It goes down, up, down like that. So it looks something like that, okay? So as my x values go to the positive direction, what happens to my function over here? Up or down? Up, so it goes to positive infinity. As my x values go in the negative direction, what happens to my function? Does it go down or up? Down, so this is negative infinity here. So you guys understand how you figure it out. You guys starting to get the idea. So if your function goes down when your x values go to the left, that means you have negative infinity. Your f of x going to negative infinity. If your function goes up as x goes to positive infinity, x goes this way, your function is going up, that means you have positive infinity for your f of x. Going upward, going to positive infinity. So you don't have to draw the sketches if you don't want to. All right, let's try another one. So for number 4, we have this function, and what's the classification on this?
Negative odd.
Good, negative odd or odd negative. You'll often see it said as the odd first or odd or even first, but either one's fine. So this is negative odd, which means that my end behavior is up, then down. So that one looks like this. So it goes up, and then it comes down, something like that. So let's look at our limits here, basically our limits. So as x goes to positive infinity, so as my x values get bigger, going off to positive infinity this way, what happens to my function as this happens? Does my function go down or up? Goes down. My function goes down over here. See how my function's going down as the x values get bigger to the right. So this, it basically says, as my x values go to the left, so as my function, we look at my function on the left side over here. What's happening to my function as my x values go down? My function's going up. Function's going up. Okay. Moving on. So, is this function in standard form? Yes or no? Yes, it's in decreasing degree order. Highest degree, next degree, right? So, what's my classification here? Look at my first term. Negative even. Negative even. Okay? What's the end behavior for negative even? Down, down. Any questions so far? I can't tell if I'm going too fast or too slow for you guys. So give me something. Okay. So, if we look at our graph, my graph looks something like this. Okay, it's going downward on both sides. So, as my x values get bigger, as we go to the right of my graph here, what's happening to the function? Is my function going down or up? Down. As we look to the left of my graph here, we look to the left side, where the x values are negative, over here. Is my function going down over here or up? Down. Negative infinity. Making sense so far, how we're getting these? Yes? Okay. Just checking. Okay. Moving on. You need more time? Some of you? Okay. So, number 6. Is 1/2 positive or negative? Positive. It's okay to have fractions, they just can't be with the variables. So the numbers can be fractions, the coefficients, but the variables or exponents can't be fractions. So, this is positive, odd, or even? Positive, odd. Okay? So what the graph looks like for this, well, the graph would look something like, well, positive, odd, what's the end behavior look like for that?
Down and up.
Down and then up. That's from your chart, okay? So the function goes like this. So, as my x values go to the positive direction over here, what happens to my function? Does my function go up on the right or down on the right? Up. And for this one, as my x values get small, so as we go to the left, is my function going down on the left side or up on the left side? Down. Negative infinity. So if we're going down, it's negative infinity. If we go up, it's a positive infinity. So how do you guys feel about figuring out the end behavior? Good? Okay. Good. So we're going to go into another step of depth here. It's just going to talk about how we figure out how many turning points our function has, basically. So, and if anybody needs more time, I'm happy to come back to these slides if you need it. So these questions, I don't remember what the phrasing of the question says, unless I look at the packet here. It says, identify the signal of the leading coefficient if the function has an even or odd degree and what the degree is. All right, so now we're going to have to talk about some other factors to do with this. So we see that my end behavior is down and down, right? So what does that associate with down and down and down? Good, negative even, right? So this is negative even. But they also want to know what the degree of the function is. So I'm going to teach you a way to figure this out, an easy way, okay? So the way I always say to figure it out is how many basically turning points your function has. So how do you determine a turning point? Well, a turning point basically looks like a bump, like a camel bump, basically. So our function has 1, 2, 3 turning points. You guys see those 3 turning points? It's basically where it loops around. So there's 3 turning points. So to figure out what the degree of your function is, the degree of your function is always the number of turning points plus 1. Okay, the degree of your function is always the number of turning points plus 1. However you want to put that, or you just want to memorize it, that's fine. But that's how you determine what the degree of your function is. So if we have 3 turning points, what's the degree of my function? Yeah, this is a 4th degree polynomial. And we have a word for a 4th degree polynomial. What do we call it? Starts with a Q. Yeah, quartic. Good. So you can figure out what the degree of the polynomial is just by looking at them. Let's look at number 8 then. So for number 8, we're looking at this function here, okay? So this function, we have to determine how many turning points it has, right? So how many turning points does this function have? 2. And what's the end behavior of this function? Down then up, which means it is? It would be odd what? Negative, right, I think? Oh, no, it's odd positive. You guys are right, odd positive. Good. Odd positive because of the end behavior. And there's 2 turning points. Two turning points. So what's the degree of this function if there's 2 turning points? Good. 3rd degree. And what do we call a 3rd degree function? We have a name for this one. Cubic. Very good. So this is an odd positive cubic function. Odd positive cubic function. So any questions about this so far? All right. All right, so moving on, we're looking at turning points. So a turning point is the point at which the function changes direction. So that's where the bump occurs, is where your function is going to go from up to down or down to up. The minimum and maximum values are called the we call this the extrema. So the word is extrema that you're going to put in that blank there. Turning points define where the function is increasing or decreasing, and every polynomial has a degree n, which is at most n minus 1 turning points. So see how we talked about the turning points? You always add 1 to the turning points to get the degree. So if you want to go from degree to turning point, you subtract 1. That makes sense to everybody, that idea? Okay. So let's go ahead and see if we can figure this one out. So first thing we're going to look at is end behavior here. So as my x values go to the negative direction, okay, as I'm looking at my x values to the left, what's happening to my function on number 9? Is my function going down? Yeah, it's going down, so negative infinity. Now over here, as my function goes to the positive x values over here, positive, what's happening to my function? Up or down? Up, so positive infinity. So now we want to determine if this function is odd or even. So we look at the end behavior, it goes down then up. Is that odd or even behavior? Odd. Odd because it goes down then up, right? And then, what's the sign of my leading coefficient? Positive or negative? It's going down then up, so it's positive. You got to look at the chart for this one. So we see that it's down then up, so we look at our chart, and the chart tells us it's odd positive. So I'm going to zoom out for this because it's a little hard to fit all here. So now for our next step. For our next one, number of real zeros. So real zeros are how many times your function crosses the x-axis. So if we look at this function, how many times does this function cross the x-axis? 3 times. So 1, 2, and 3. So the number of real zeros is 3 because it crosses the x-axis 3 times. Zeros are how many times we cross the x-axis. Now we're going to come back to letter E later because it's going to be easier to figure out after we figure out some other information. So we're going to come back to this one. We're going to state the domain. So my function goes to the left forever and it goes to the right forever. So the domain is? Good. Negative infinity to positive infinity. You're close. And now we're going to talk about the number of turning points. So that's the number of basically camel humps your function has. So my function has 1, 2, 3, 4 of those. You guys see all 4 of them? Everybody see that? Okay. So how many turning points does my function have? 4, right? Okay.
What's the imaginary zero?
I'm going to come back to it. Yeah, we skipped it on purpose because I'm going to show you how to find it. You have to find something else first. Did somebody else have another question? I heard somebody else say something.
How come you didn't add 1 to the turning point?
The number of turning points is 4, but when you classify the polynomial, what's the degree? Then that's where you add 1 to that. Does that make sense? Okay. So the number of turning points is 4, but the polynomial is 5th degree because you add 1 to the 4. So it's 5th degree. And do we have a word for a 5th degree polynomial? It's on your old note. Quintic. Quintic. So that's a quintic polynomial. So your classification is always your number of turning points plus 1. Number of turning points plus 1. Now we want to talk about the number of imaginary zeros. So the number of imaginary zeros is always your degree minus your number of real zeros. So it's the degree minus the number of real zeros. So what would that come out to be in our particular case? 2, because 5 minus 3 is 2. So that's how you get the number of imaginary zeros. Everybody see how we got that? Everybody with me on that? Okay. You guys ready to try another one? So now we're going to look at number 10. So we look at our end behavior. As my x values go to the left, okay, this way, is my function going up or down? Down. So this is negative infinity. It's going to So it's going to negative infinity. As my x values go to the right, as my function goes to the right, is my f of x going up or down? Up. So positive infinity. Is this function odd or even? Odd. You guys see why it's odd?
No.
You see that chart on your first page? So odd functions always go up, down, or down, up. Bless you.
Yeah.
And then what's the sign of the leading coefficient? Positive or negative? This one goes down, then up, so it's positive. So B and C are right from the... Anyways, so these are from the chart. Now, number of real zeros. How many times does this function cross the x-axis? Just once. Very good. That's how many times it crosses the x-axis. If you want to write x-intercepts next to it, you can, okay? We're going to come back to E later. Okay, I like to do E at the end. It's the easiest way to figure it out. State the domain. This function goes on forever in both directions. So negative infinity to positive infinity. Now, the number of turning points on this one is a little bit tricky because if you look at the function really close, okay, zoom way in here. If we look at this function, there are turning points. They're just kind of more flattened. So there's a camel hump right here and right here. You guys see those? Those turning points? They're just very like flattened, but they still exist, okay? So how many turning points does this function have? 2. So there's 2 turning points on this function. Everybody see the 2 turning points, how we determine that. Now, we're going to classify the polynomial. But how do we find the degree classification again? Good, so what does it come out to be? 3. So this is 3rd degree, and we have a word for that, which is? Cubic. Good. And do you guys remember how to find the number of imaginary zeros? Yes, which comes out to be 2. So it's H minus D, basically. You guys get the idea of it? So, you guys have a try your own question. So here's the answer to the you try question. Look over your answer with my work and make sure that you have the same thing. We're going to break until lunch. I mean, you guys can work on your homework if you want. But when we come back from lunch, I'm going to go over homework problem, like some of the problems with you guys, because I want to just make sure you guys know how to do them.
Is this on that?
3.4, yep. So the way the homework's set up, when it says polynomial, it wants to know if it is or isn't a polynomial and why. So some are not polynomials according to some of the exceptions, right? So you can't have more than one variable, for example. Hint.